The height of a pole is 2 root 3 meters. The length of its shadow is 2 meters. What is the angle of elevation of the sun? So this is the pole standing on the ground whose height is 2 root 3 meters. So this is 2 root 3 meters. Okay, now let this be the sun here. Now it is said that the length of the shadow of this pole is 2 meters. So this sun, it shines its rays like this at a particular angle, and which happens to be the angle of elevation of the sun with respect to the ground, isn't it? So this is the shadow, and the length of this shadow is 2 meters, right? And we have been asked what is the angle of elevation that this sun makes. So we can write tan theta is equals to opposite upon the adjacent side. That's 2 root 3 upon adjacent is 2. This 2 and this 2 gets cancelled out. So we have tan of theta is equals to root 3. Now if you refer the trigonometric table, you'll find that tan of 60 degrees is root of 3. Right? So I have theta is equals to 60 degrees. So the answer is option C. Okay, so you should remember the trigonometric table properly in order to solve such questions. What is the angle of elevation of the sun when the length of the shadow of a tree is root 3 times its own height? So this is the tree, and this black one is the shadow of this tree. And we have been asked what is the angle of the elevation of the sun. So the angle of elevation of the sun with respect to the ground will be this angle theta, right? Now what else is given? Well, we have been given that the length of the shadow is root 3 times its own height. So let the height of this tree be h. So the length of the shadow will be root 3 times h. Okay, so if I take tan theta, it is opposite upon the adjacent side. So I can write this tan theta is equals to opposite is h upon adjacent side is root 3h, right? H and h gets cancelled out. We have tan theta is equals to 1 by root 3. Now if you look at the trigonometric table, you'll find that tan 30 is equals to 1 by root 3. So theta is equals to 30 degrees here. So option A is the correct answer. From a point P on a level ground, the angle of elevation of the top of a tower is 30 degrees. If the tower is 100 meters high, what is the distance of the point P from the foot of the tower? Okay, so this is the point P and this black one is the tower. Now we have been given that the angle of elevation of the top of the tower is 30 degrees. So if we look at this top of the tower from point P, the angle of elevation is 30 degrees, right? And we have been given the height of the tower. So this is 100 meters. Okay, and we have been asked what is the distance between the point P and the foot of the tower, and let that distance be x. Now if I take tan 30, it will be equals to the opposite side upon the adjacent side. So 100 by x. So this is 100 divided by x. Now tan 30 is equals to 1 by root 3 from the trigonometric table, and that is equals to 100 by x. So I can write x is equals to 100 times root 3. Well, what is the value of root 3? Well, it is 1.73. So 100 times 1.73, right? So this is equals to 173 meters, right? So option C is the correct answer. A ladder leaning against a wall makes an angle of elevation of 60 degrees. The foot of the ladder is 4.6 meters away from the wall. What is the length of the ladder? Okay, so the situation is kind of shown in this figure. This ladder makes the angle of elevation of 60 degrees. So this angle is 60 degrees, right? And the foot of the ladder is 4.6 meters away from the wall. So this is the wall. This foot of the ladder is 4.6 meters away from the wall, right? And we have been asked what is the length of the ladder. So let this length of this ladder be x. Okay, so we have the adjacent side and the hypotenuse of this right angle triangle. What can we do is take the cos of this angle. So cos of 60 is equals to adjacent upon hypotenuse, that's 4.6 upon x. Well, the cosine of 60, if you look at the trigonometric table, you'll get it as 1 by 2. Cos 60 is half. So this is equals to 4.6 by x. Right, so therefore I can say x is equals to 4.6 times 2, and that is equal to 9.2 meters. So the length of this ladder is 9.2 meters, and that is option D.